So this is the technology I have to fit into it. Everything you see here, and probably more, has to be fit onto the machine someplace because everything here has a purpose. So what I want to do is go through the technology. I'm waiting for the paint to cure anyway. One thing I know about myself in my career, waiting for paint and glue to dry has been my downfall. So I am going to give that paint 4 or 5 days or a week to get to completely cure. I'm not sure that's going to help or not, but it can't hurt. I have a lot of technology to organize here. So when you're doing a project like this, it's always good to keep ahead of where you actually are. So what I'm doing now is I'm just gathering all the things I need, all the things that I know have to go on this thing. And then from there, I'm going to figure out where it's going to go and how it's going to interact and all that kind of stuff. But this is the stuff the technology that I own, that I want to get onto this machine someplace. And there's some stuff that's not here that's going to go on, but we'll talk about that as I put it on. So let me start at this back corner over here. So as we've seen before, this is the drive motor to make it for propelling the machine. 6 horsepower, 8 horsepower, I don't know, something like that. The specs I look at are all different. I have it fixed up. I think it's in pretty good shape now. So I think I don't think that's going to be a problem. So I have the mount completed. So the mount for the motor. I originally had designed this to be on some sort of pivot so that the torque from the motor could apply a brake as you slowed down. I'm going to still use the hardware for it, but I'm going to lock it out. I'm just going to not put the pivot in, or not have the pivot actually pivot, because I have a different idea that should work even better. So here up in the front, I have the power for it. So this is going to be an emergency shut-off, or a battery shut-off. This isn't an emergency one. An emergency button you should be able to smash with your hand, if it's going to hit you or something, or if it's getting out of control. But I want to get one that they have available now for remote control. So it's kind of a separate remote control system from the one you're using to control it. And it's like kind of a big red button I don't know where, someplace, or sit on the table. And then if something goes wrong, it sends a signal to the machine to shut it off. This thing's going to have some mass to it. If somebody gets in front of it, I need to be able to kill it quickly. This has to be safe. So this is going to just turn the battery on and off, and then something else is going to actually be able to shut the machine down as it goes. Here's some cables, some different cables I've had from other projects. I like these type of connectors. You can disconnect the batteries easily and quickly to disable the machine. I haven't checked the gauge of this stuff, but I'm confident that it's going to be big enough for the kind of amperages I'm running. Because we're running 48 volts, our amperage isn't going to be that high, and you'll understand what that means as we talk more about electricity and current flow and that kind of stuff. So here's just some miscellaneous cables I've got. It saves me making new ones. It'll help me decide where things need to be positioned by how long these original cables are. If I can move something 2 inches closer and use this cable instead of making a new one, then it's just a good idea to not waste this stuff. It's just too valuable. This is a 48 volt to 12 volt DC to DC converter. I don't necessarily need it, but this is going to be a 48 volt system. I have it. I'm going to install it. It's always good to have 12 volts. I have a 12 volt system on this machine. I have a different plan for that, but I'm going to put this on just as kind of a backup, and I own it. I might as well use it. There's lots of room for it, so it shouldn't be a problem. Again, the Robotech speed controller. This is going to be very interactive. We can log in with a computer. We can log in with other computers. It has serial control, analog control, digital control, PWM control. It does everything. You can put encoders in it so it can count motor revolutions. This is a very high-end, for my level of projects anyway, high-end speed controller that should more than handle the current that this thing's going to have. Very lucky to have that for this project. So the next thing are the batteries that we've seen before, right? So here's 4 batteries. Here's my 48 volts lithium-ion batteries, 1, 2, 3, 4, and then this is the battery charger for it. So rather than have this mounted and have to plug this in when you charge the machine, I'm just going to mount this in the machine someplace, and you just come up and maybe you plug one of those, the 3-prong plugs into it or something, or just plug this into the wall, because there's going to be more than this charger on it. This is a 48 volt charger. And I'm going to have another 12 volt battery that probably deserves its own charger as well. So I might as well plug those in together on the machine and plug one plug into the wall. So this is just the charger. I think it's 5 amps at 48 volts. So this battery, this is the 12 volt battery I want just for the steering. The steering system I have is a 12 volt. And I don't want to have to rely on the power converter, DC to DC converter. I want to have its own battery, just so I don't have any current problems. This box you see on top is a charge controller. This is out of a previous project. I had some lights on my deck powered by this battery and charged by a solar panel. So this is the controller for that panel. And actually, this is the panel that I would like to use. Let me just lift up here. So I would love to put this solar panel on this machine at the front someplace to keep this steering battery charged. That's what the small battery is for, is the steering system. The Propel is 48 volts, but the steering motor, the one we've been building, this one's only 12. So I need a whole electrical system for this. I'm worried that this is going to draw more current than that little DC converter will do. So the battery will supply the current, and then I'll probably just keep the battery charged up either with solar power, because I don't think there'll be there won't be as much duty cycle on the steering as there is on the drive. So there might be enough energy coming out of that solar panel to make the other battery charge up, but I don't want it to be ugly either. So we've been talking about how to make the machine move forward. We also need to figure out how to make the machine stop. And originally I was talking about putting some sort of linkage on the pivot of the motor and when the torque forward, backward, blah, blah, blah. I think I'm going to I'm going to put a brake system in it. There's a couple things I have. So this is the hydraulic master cylinder, and the vehicle has a rear disc brake on it. So if I can operate this somehow, this could be brakes for the machine. The problem is, how do you activate it? Normally your foot would push against this lever, but nobody's going to be in the machine. So we have to have some way of activating this thing. So there are things called linear actuators. This is a version of it. I have a couple of different ones of these. This one happens to be a throttle control out of a small excavator. I want to see if this has enough force to push this brake pedal in. Somehow build this into the brake system, and then when I operate the remote control radio, a controller, some sort of board would send power to this plug. There's a potentiometer built into this, so the computer will know how far this is out, and so it would know how far it's pushing on the brakes. So this is a version of what I have. Again, I have a different one of these, but it's the concept of, can you make the timing of this happen well enough to be safe? I think so, but I'm going to work on the front brakes first. The front brakes on this vehicle have drum brakes operated by a cable. So I could, for now, just have this actuator pull on or push against a spring that pulls the cables or something. I think by putting a spring in between here and the brakes, you can adjust the amount of torque, right? Even if this thing over torques or pushes too far, you won't damage the brakes or break the cables. I'm not sure yet. For now, I'm just going to rely on regeneration to slow the machine down. And, if it becomes a problem with needing brakes to stop, if I can't just plug the remote into reverse, then I will probably work on something like this for the rear brakes first. I think it'll be easier, and then it just applies the rear master cylinder. So again, we've looked at the steering for this. I've ordered potentiometers to go on the bottom, or a potentiometer to go on the bottom, so I need to put some sort of measuring device that measures where this arm is. And then it controls whether this goes left or right and how much and how fast and all that kind of stuff. So this is the new mount to take the torque, to put the torque from here into the frame of the machine so that it doesn't go through the bolts of this. Now all of the torque will go straight up the middle, because the bottom of the shaft is held by this block. The top of the shaft is held by a bearing inside here. The bottom of this housing is held by this piece, and the top housing is held by this piece. So everything here is grounded and centered, concentric. So this should be as sturdy as it's going to get. So to drive this thing, ultimately, what I'm going to do first is start out with the machine being remote control. So this is just a basic remote control radio. This is what I have all my models in, all my vehicles and stuff. So forward, back, left, and right. So just having it on one. Could have the steering on this one, but I've been used to skid steer machines where everything's on one. So I would probably just have this for controlling the vehicle. And this one, I think what I want to do is using this and this controller, which I'll talk about in a second, I want to make pushing forward on that stick be the brake. So when you push forward on that stick, this actuator comes out and puts the brake on. So that's so forward, reverse, left, right, and brake on. And maybe this way does something. Maybe one way is front brakes and one way is rear brakes, and to the left is both brakes. I want to see I think the code for the steering is going to be the same code for the brakes. And what I mean by that is, so let's get into that part of it. So to control the motor for the steering, we need to send it electricity based on what the remote control radio wants. So we have to analyze, we could just put that through the receiver and have this run through a motor controller directly from the radio and have it steer, but the problem is there's nothing to tell this motor to return back to center when you let go of the lever. Notice this lever is spring-loaded, right? So when you let go, and in your car when you let go of the steering wheel, it goes back to center. You don't have to steer back to center. So I want this to do the same thing because I want it to feel right. I think it's not going to be safe unless the machine returns to center when you let go of the lever. So what's going to happen is, this works for a remote control servo, for a remote control airplane or something like that, but it won't work for this because this is not a servo, this is a motor. I'm going to make it into a servo by putting a position sensor on the bottom and some sort of control. Well, this is an Arduino. This will control the output, some output pins here to control a speed controller. This controls the current to the motor when given a signal, and this is what sends it the signal. So this microcontroller will receive signals from the remote control radio saying the lever wants the center. It will go out, find out, it'll measure the potentiometer on the bottom of this servo and say, is it centered? No, it's not. So if it needs to go to the left to make it centered, it measures that and sends a signal to this, or figures that out, how much signal to send to this to steer it left to make it center. So this is going to analyze the radio. What does the operator want? What is currently happening? If it's not right, what do we have to do to make it right? And it keeps doing that until it is right. So that's what they call a feedback system. So this thing, this is going to do a bunch of things. It's going to control the steering, and if the code for the steering works, it's also going to control the code for the brake actuator, because I think it's the same code. How far has somebody moved the lever? And instead of now deciding what angle that goes on, it will decide how far this moves out, because there's a position sensor inside here that says, okay, it's out half an inch. And by calibrating and measuring and trial and error and lots of frustration, I think I can probably make that work. So this is going to control probably brakes and steering and any other thing that I want to put on it. If I want to make headlights turn on and off and stuff. So this has logic to it. You can write code to this in C++, and you can make this do all kinds of stuff. It makes this whole project very versatile. I can bolt anything to it and have this through all kinds of other connections. Like this here is called this is the boron. This is kind of an interface to a vehicle. It would interface with this, and this has a 2G connection. So I can get I would end up getting a cell phone service for this, and for like a couple bucks a month, I can now transmit the information from this to a web page or to my cell phone or something through a 2G connection. It doesn't rely on Wi-Fi. This is 2G. So I had this. I've been trying to think of a good project for it. The project I had for it got kind of canceled. So I have this available, and I want to put it on here because I would love to, transmit information from this back to a web page or something, just to see if it can be done. Also on the control side of it, these are just relays. So a relay takes a small signal and converts to a big signal. Now these ones are kind of a little bit more advanced. I can send signals from the Arduino to these to control them. So through the remote control radio, through some logic to find out whether we're going to turn these on or off. But these ones are a bit unique in the fact that they can plug right into the receiver from the remote control radio, and when I can program it so if I flick a switch, one of these trips. So I can use this for headlights or a siren or a horn, or what I'm going to put on it is something like this. This is a xenon strobe. So these things flash really bright. This thing's going to be moving around where people are. It needs to be safe. It needs to be seen. So I'm going to put this on here, and it'll probably be on all the time, but when it's really obnoxious and you don't want it on, you maybe flick a switch on the radio and you can bypass it and it turns off, or have this controlled by this Arduino. So if something happens, or if it senses somebody in the way, I can put sensors on the front. So if it senses a person or something in the way, maybe this can start to flash and something can happen. So there's some sort of warning. There's lots of room for it. I don't see why it's not a problem. This is, the remnants of, but this used to be a flight controller for a drone. This thing's been in several projects. It's a bit worse for wear. I think the case is busted. I could probably just use the board. I think it still works. I think I can program this to control the steering and the throttle on this thing so that I can make this vehicle somewhat autonomous. I can set it loose in a park behind my house, or in a back parking lot of the school. I can draw a picture on a map on Google Earth, for example, and send it to this, and this controller talks to the speed controller, the big blue box we saw earlier, and tells it whether to go forward or back, and it would also talk to, interface with this, with the Arduino, and have it steer one way or the other. So it takes over this kind of interrupts the signals between remote control radio and speed controller, and tells the vehicle to follow a certain path. There's GPS is plugged into this. There's compasses plugged into this. This is pretty cool. This one's a bit antiquated. There's newer versions of this. So I'm going to look into what the kind of latest and greatest is for rovers. Most of these are designed for quadcopters or airplanes. I want to see if I can find one that's more rover based, because this thing is never going to fly. So I want to see if I can find a kind of a rover based, maybe even a little more professional type. The problem is this is all open source software. People are modifying this, the software and the control software and the monitoring software. People are always making it better and better, and it's nice because it's cheap. You just keep upgrading, and it's a great way to see how the industry is coming along at a fair price. But I also want to make this thing be professional. This may end up getting in a competition someday, and I don't want to rely on hobby stuff when we should have put the proper stuff in. So I'm going to look into kind of upgrading the flight controller, as they call it. I also have this. So this is out of a previous project, and I apologize for being so filthy. I just found it under a bench. It's one of these inside a box with a bunch of potentiometers and plugs and switches and stuff. So this is kind of a more robust mount of this, and it's wired inside, like I get USB and power and all kind of stuff. I made this myself for a previous project, and I want to reuse this for something. And the fact that it's all mounted in a really sealed, heavy duty box with relays and infrared. This is an infrared receiver. Like, this thing's got lots of technology in it. So I think I'm going to clean this up and mount this on the vehicle as this. And then these cables can talk to whichever boxes they need to. So I'm looking forward to getting this cleaned up and looking pretty again. And so this is one of the control boxes. Everything else is going to mount in this one. This one's probably going to have antennas sticking out of it. It'll have the flight controller in it. So we'll have this mounted in it. It's also going to have video. This one has it's called FPV, first person view. So there's on the vehicle, this is a 1080p camera, very small kind of action cam. And combined with this piece, which is a transmitter, this can transmit a video signal. And then it transmits back to a video receiver on the ground. And this video receiver can be monitored on any kind of, for what I have, any kind of analog signal monitor. This is something for FPV. When I was into the drone hobby, I still have it. It's a bit small. I'm trying to make a newer ground station using a fairly large television, like a 30-inch television. So, you don't have to search through this thing. But this thing's nice when you're out. This thing typically mounts to the top of a radio so that you can see what's going on while you're driving it, and that's so you don't have to take your eyes off the vehicle or off the radio when it's out of view, right? So this is when you're operating this vehicle and you can't see it. All you can see is that what it sees through this camera. So the other side of the radio, the sideways of the radio, will probably turn the camera. I'll have it pointed slightly down on the ground, and then by operating the side to side of the left stick, you'll be able to look around while you're driving. More technology is coming. I have a kind of an ammeter, a new ammeter, watt meter coming. It should be here this afternoon, actually. And whatever other things I find as we go along. There's a lot of stuff here to figure out where it goes. This is the fun part. This is the part I like the most. Getting all these things talking to each other and the electricity flowing. And when you hit a switch, things happen. Lights come on and things beep. So I'm going to start figuring out what I have, what I don't have, what I need to order, what needs to be repaired, what I'm actually going to use, etc., etc. I'm going to try making the brake system. Actually, know what I need to do? The first thing I need to do is get this steering working. Potentiometer should be here today. I need to get this operated by this from this. So that's probably the biggest technology hurdle right now. I've looked online. There is some code people have written to do kind of similar to what I'm doing. So I'll be able to get that even just for ideas and tweak it and make it my own. So that's it. Paint is drying. Technology is waiting.